All right. So now DynamoDB is all about to store and read data for you, right? So definitely, data consistency is one of the key factor to use DynamoDB. As an architect, you must be clear before taking any consistency option here that what kind of consistency in data you need, what kind of consistency in data to be read you are assuming in your service, in your development, right? There are two different kind of model or option you would say provide by DynamoDB. One is called strongly consistent reads and second is called eventual consistency read. DynamoDB providing eventual consistency reads as a default behavior. But let's say you have a requirement where you need a strongly consistent reads behavior. In that case, you have to choose that option. If you are not choosing anything, by default, it will be eventual consistency. Let's go to one by one. Now, as I told you, there are two different kind of options provided by DynamoDB. One is a strongly consistent, right? And a strongly consistent kind is like, if you try to understand what is this, then you would say that when you request a strongly consistent read, DynamoDB returns a response with the most up-to-date data, reflecting the updates from all prior write operations that were successful. Strongly consistent ensure that if you had just written data to DynamoDB, a subsequent read would return that data. How it is implemented will come later, not now. So there is a story behind it, how you will achieve it, but that you definitely have option to do it, right? However, a strongly consistent reads require more resource and might also exhibit higher latencies, especially in a distributed database where data might be replicated across multiple locations. A strong consistency is not the default behavior of read operation. In DynamoDB, you must explicitly request for it. Okay, clear? Let's move to eventual consistency now. Option is eventual consistency read, which is the default behavior. An eventual consistency read might not reflect the result of a recently completed write operation. The consistency across all copies of data is usually reached within a second. Repeating a read after a short time should return the updated data. But if you go for the immediate, just after the writing, probably you will get the stale data in that case. Eventual consistency meaning it is guaranteed that your data will be updated, but it is not guaranteed that it is updated right now. That's why it is called eventually consistent. Okay, so data would be consistent eventually. Reads are usually faster and costs less than strongly consistent reads because they can be served from any replica of the data that has received the updates. For applications that do not require the most up-to-date data and can tolerate eventual consistency, this model provides a more economical and faster read experience for you in your service. That's why, as an architect, you must be clear which option you have to choose. Is it the strongly read consistency or eventual consistency read? Which option is better for you? It depends on your requirement and your decision. But whatever the decision you are taking, you have to write those decisions because that decision help you to understand what is going on right now. Okay, I hope you are clear now. Let's move to the next segment. Here are some considerations when choosing between a strong and eventual consistent. These are some thumb rules, so that's why I'm giving you this information. But it is not necessary that you should follow this way only. It depends on your requirement also or your context also. But there are some general rules. So whatever I'm listing here, these are the general rules, general thumb rules to understand as an architect. Okay, but take your decision accordingly, your context. Okay, but this will help you to decide. Use strongly consistent reads when your application requires it, such as financial or critical operation, where reading the most up-to-date information is very, very crucial for you. Use eventual consistent reads to maximize performance, scalability, and cost effectiveness. When your application can tolerate some lag between when data is written and when it becomes visible in a read, then you can choose eventual consistency. It is important to design your application with the understanding of these consistency model, because if you are not clear, then probably you will get wrong options, as this choice can affect application complexity and user experience. That's why this is very, very important decision, and you have to always take proper measurement, proper evaluation, proper analysis before deciding any decision. Okay, some application might use a combination of both also, depending on the criticality of the data and the operation being performed. So these are the few tips and tricks for selecting the consistency model for you. But as I told you earlier also, definitely as an architect, you have to thoroughly understand your contextual requirement and then you decide. Okay, let's move on to the next segment now. Thank you. Thank you for completing this video. And I hope that you definitely have learned something which will help you in your system design interview. Hope to see you in next video with new concept and skills needed for the system design interview. By then, keep learning, keep improving, and keep sharing your knowledge.